All right, hello everyone. In today's video, we're going to talk about how to find the roots of a polynomial given either a root or a factor. So in this first problem here, I do give you the root of the polynomial at x equals 2. So let's start out by doing some synthetic division with that root so that we can bring our cubic down to a quadratic. So to set up the synthetic division, I'm going to have that root on the outside. When I go to set up my numbers on the inside here, we need to remember that we need a placeholder here. We go from a cubic term to a linear term. Our quadratic term is missing. So I'll have 1 for the cubic term, 0 for our quadratic term, -7, followed by a 6. To do the synthetic division, I will bring down the 1, and then again it's a series of multiplication and addition, multiplication, addition, multiplication, and addition. And for all these problems, we're going to see a 0 in this last spot here, which is going to represent our remainder. So if we're going to write out the factors of this polynomial, this g of x function here, we know that this root of x equals 2 translates into a factor of x minus 2. And then the answer that we had gotten down here, if we throw our variables right back in, it's one less than what we started with. We have our other factor as x squared plus 2x minus 3. So from here, we'll want to try to factor this last polynomial if it's possible. And this one is. So x minus 2 is our first factor. Our second factor, we're looking for two numbers that multiply to 3 but have a difference of 2. So we'll use 3 and 1. We want a positive 2, so it'll be a positive 3 and a negative 1. So this g of x function given to us in standard form factors as this right here. If we take each one of those factors, set it equal to 0, we get that our g of x function has zeros at 2, -3, and +1. So I'll square that for my friends that like to square their answers. If we go down to the next problem, now in this function, notice that I'm giving you a factor, not a root. So we'll have to get the root here by setting our factor equal to 0 and solving. So when we go to do the synthetic division here, we're going to have a 1 on the outside as our root. And then we're not missing any terms here. So we can go ahead and throw our numbers into our synthetic division, dropping down our first factor, and then series of multiplication, addition, multiplication, addition, multiplication, addition, and again we notice that we have 0 as a remainder. So this time if we go to write our f of x function in our factored form, factor is the x minus 1 that we started with. And then our answer down here, again, one less degree than what we started with. We can write our other factor. But now if we try to think about factoring this farther, we realize that we cannot. There are no two numbers that are going to be factors of 13 that are going to add up to 4. So we have choices here. To figure out the roots that are associated with this quadratic factor here, we can either do quadratic formula or completing the square. I personally like completing the square for this process because our a term is equal to 1 and our b term is even. So if you want to do quad formula, feel free, but to complete this problem, I'm going to choose to do completing the square. So to complete the square, I'm going to take my factor, set it equal to 0, bring my c term over to the other side, and then to actually complete the square here, we're going to have to take our b term, divide it by 2, and square it. So -4 divided by 2 is -2. -2 squared is 4. So I'm going to add 4 to both sides of our equation here. And now this turns our left-hand side into a perfect square trinomial, which factors into x minus 2 quantity squared. The right-hand side, when I combine like terms, is a -9. From here, in order to solve, to undo the square, we're going to take the square root of both sides. So that's going to bring us to x minus 2 equals. Remember when we take the square root of both sides when solving, that gives us plus or minus options. Because we have a negative under the radical, that translates into an I outside, and then the square root of 9 is 3. Last piece of our puzzle here is that we will add 2 to solve for x. So we get 2 plus or minus 3i. So remembering we have that 0 along with the 0 that we had figured out before. So remembering we have a cubic function, so at most we're going to have 3 zeros. In this example, we had 2 complex roots and then 1 real root. Thank you for watching.